Hello, and welcome to another episode by the Year Mathematics channel. So for today, we have a question we're going to be solving, and it's a differential equation question. So we say we should solve 1 plus y squared equal minus 1 multiplying and dy over dx plus 2x multiplying tan inverse of y equals x cubed. And how do we approach this form of question and put our solution? The first thing that's proper in team is to take tan inverse of y represented by a letter. So I'm going to say let a tan inverse at y be equals to the letter u. So the next thing I'm going to do now is to write this having u at the front, u equals tan inverse of 1. So I'm going to differentiate u with respect to 1. Alright. So if I differentiate u as du over dy now, because of the tan inverse, we write the tan inverse of maybe x or y as 1 inverse 1 plus y squared. They're actually special identities, right? That's how we express them. So the next thing I'm going to do is I'm going to write what I have on the right hand side to be 1 plus y squared to become minus 1. That's because of the 1 over, according to the law of indices. Now, the next thing I'm going to do after that is that I am going to cross multiply this so that my du becomes 1 plus y squared to power minus 1 dy. So I'll call this at equation 1, what I have. So the next thing I will do now is to substitute 1 plus y squared to the power minus 1 dy into this equation for this. So I'll probably want to write this equation so you see it very clearly like this, so that this 1 plus y squared to the power minus 1 dy becomes du. So all the thing at the top will become du. So I'll just have here du over dx plus 2x. Now tan inverse of y, remember we made it u from the beginning. We have a u here equals x cubed. So I'm going to call this equation 2. So when you observe equation 2 very closely, you see that equation 2 represents a linear equation out of the equations we know for and differential equations. Linear equation is one of the equations such that the derivative function has a power of 1, and also the dependent variable, which in this case is u, is also in the power of 1. So anytime you have an equation such as the derivative of the function in that equation has a power of 1, or we say has the degree of 1, and also the independent variable in that expression too also has a degree of 1, then we can say that that equation is a linear equation. So I'm going to say since 2 represents a linear equation, and what's that formula saying? So you have y times the integrating factor equals the integral of q times the integrating factor dx. The standard linear equation has this particular form: the y over dx plus p of xy equals q of x. So the q here represents the x cube, you can see here. The p of x represents the 2x, you can see here. And y represents the u in this case, because obviously we're dealing with the integrating, we're dealing with the linear equation. So u represents the y that you can see here, and the y over dx represents the du over dx. So for this now, I am going to, and the integrating factor, let me mention that, the exponential, the integral of p of x dx. Right. So first of all, what I want to do first is to get the integrating factor. So I'll call this at equation 3. So the integrating factor is going to be the, like I said, exponential to the integral of p of x dx. So in this case, my p of x comparing is going to be 2x. So my integrating factor will be the exponent integral of 2x dx, since p of x is 2x in the equation. So if I'm going to evaluate this, I'm going to have an exponent. The integral of 2x dx is actually x squared, and that's what I have. So at the end of the day, I can say that my integrating factor is actually exponent of x squared. That's exponential of x squared. Right. So this will be my integrating factor. So I'll just call it in star. So what I want to do now is to put in my integrating factor into this expression. That's equation 3 here. So further simplify what I have. So I'm going to have substitute star into equation 3. So I'm going to have something of this nature, right? Y times e to the power of x squared equals the integral. Now my q, if I go down, it does have my q represents the x cube here. So I'm going to have integral of x cube times the exponent of x squared, or the exponential x squared, then I have dx, right? So the left-hand side would actually be solved, but let me first write as y exponential x squared equals integral of x cubed exponential x squared, then dx. So I thought I want to simplify this. Let me call this equation 4. So what I want to do first is simplify the right-hand side, which is where I have the integral of x cubed exponential x squared dx. And that one actually take a different turn, right? Because I'll probably have to apply an integration by part to actually further evaluate it. So how do I do that? So for the right-hand side of the equation, right, we don't have something of this nature. Integral of okay. So I'll probably want to change this my y on this side to u, because like I said, the value I have is u, not y, for my dependent variable. So I have u times this, and I have u exponential x squared. So what I have there now, from the right hand side of the equation here, I'll probably want to just say the integral of x cubed exponential x squared. So I could just say let, first of all, x squared, which is at the exponent or the exponential, is equal to area letter v. Then I'll probably differentiate v with respect to x. So I have dv over dx, definitely will give me a 2x. So what I have now, I can just make dx the subject, because this is a dx here. Making dx the subject, I have my dv equals 2x dx, and the x becomes v over 2x. So I'll take this dv over 2x and put it into the equation here, substitute it. So if I do that on the side here, I'm going to have an integral of x cubed x cubed, then exponential v, because x squared is v now, then dv over 2x, and that's because dx was made dv over 2x. That's from here. So x will cancel one with x cubed, so I have the integral of x squared dot exponential v in v over 2. So the 1 over 2 can actually come out of the integral sign. So I have 1 over 2 integral of x squared exponential v and dv. Right. And once I've done that, now I can see that I made x squared v. So I'll replace this x squared here with v. So I have 1 over 2 integral of v exponential v and dv. Alright. So this is one side of the equation. I'll call this equation 5. So for this particular, what I've done, broken it down, I'll still have to apply the integration by parts to this. Integration by parts to this. And to do that, that's the integral I have here. I'll say let mu be equals to v, and let dv be equals to exponential v. My du here is going to be 1, that's du over dv, and my v here is going to be still exponential v. So I'm going to put that now into this equation here, equation 5, that's the inside the integral sign. So I have a 1 over 2 integral of sorry. So what I'm going to do now is to apply the equation by parts, which actually goes that the integral is uv minus integral of u, the derivative of u times v. So my u is v, my v is exponential of v minus integral of I differential is 1 for u times my v is exponential v. So I have v exponential v minus integral of exponential v. And if I go down, that should give me v exponential v minus exponential v. Alright, so at the end of the day, my integral here will be exponential v into bracket of v minus 1. So at the end of the day, equation 5, as you can see at the top here, would definitely become 1 over 2 exponential v into bracket v minus 1. So I've successfully now finished up the derivative of this one, x cubed exponential x squared, as from equation 4 here on this side. So I'm just going to replace that with exponential v minus 1 and 1 over 2. And if I do that, right, I'm going to have something like this. Watch me do that. So let me go back so I can see this very well, as you can see on the side here. On the side here, to remember, I made v x squared. So on the left hand side here, I'm going to have u. I'm going to have, let me say from equation 4, I'm going to have u exponential v equals 1 over 2 exponential v into bracket v minus 1. So I'm going to divide both sides by exponential v. But before I do that, I omitted my plus c, which is actually part of the integral you must do, so I had a plus c to it. So I'm going to divide both sides by exponential v, or divide all through by exponential v. I have here exponential v, and here exponential v. So this cancels out. So my u becomes, this also cancels out. I have a 1 over 2 v minus 1 plus c over exponential v. And if I multiply 2 by 2, I'm going to have a 2u equals v minus 1 plus uc over exponential v. And because it's a constant value, right, I'll just make it 2u equals v minus 1 plus, let's call it a constant again, let's say b. So 2c, that'll be b over exponential v. 2c is actually a constant, so c is a constant value, so 2c should also be a constant. I'll replace that with v. So at the end of the day, I'm going to be having 2u equals v minus 1 plus b exponential minus v, by taking this up according to the law of indices. So at the end of the day, remember my v represents something, which was x over the initial term if I go up, probably see it. V is x squared here. So I'm going to go down now and replace that v with x squared. So I'm going to have 2u equals x squared minus 1 plus b exponential minus x squared. So at the end of the day now, I'm going to make u the subject here. So I'm going to have something like u equals x squared minus 1 over 2 plus b exponential minus x squared and over 2. Well, I can make b over 2 something, another constant, since b over 2 is a constant there. So I have u equals x squared minus 1 over 2 plus d exponential minus x squared. So at the end of the day, finally, remember that I made my u initially go up. Initially, I made my u initially, we go back. Okay, there's zero. It ends at the beginning. Let's go up. Yes, we made our u tan inverse of 1 in the beginning. So I'm going to replace the u at the bottom because I just introduced the u. The u was not part of my initial equation. So I introduced the u back with tan inverse of 1 equals x squared minus 1 divided by 2 plus d exponential minus x squared. So at the end of the day, I'm going to take my tan inverse to the other side. That's the tan here. So I have my y equals tan into bracket x squared minus 1 over 2 plus d exponential minus x squared. So this represents the solution to a problem. Right, so on the long run, it actually has been a very lengthy one, and you probably require that you take it step by step and follow it through, at least from the beginning, and see how it works. So if you have any need to ask any question, please reach us on our email address at ziglaginstitute@gmail.com. Or you could just comment at the bottom of the page and let us know your difficulties in either the question solved above, or more or less you need a certain help with a problem in mathematics. I'll be there one way or the other to deliver the best thing. Thank you for your time, and God bless you. I had a great mom and Mrs. Help.